All right, so the other property that electrons have that we use to create fields, forces, is the magnetic spin. So each electron has its own little magnetic field, usually known as a magnetic spin of the electron. And when we align these magnetic spins, we get net magnetic fields. These net magnetic fields are what cause magnets or magnetism in general. So the magnetic spins of the electrons work basically the same as a magnetic field does in general, only on a much smaller uh, area, much smaller size. But when we get the magnetic spins of electrons to work together, we can create larger magnetic fields. There's two ways that that electrons can create magnetic fields. One is by aligning these magnetic spins, as I just mentioned, and the other one is when the electrons are moving, they create a magnetic field when they move. The first we'll look at is when they're just sitting still, when they're basically in a network of atoms. Those electrons are spinning around their atoms in this material, and they have magnetic spins that are pointing in different directions. If these magnetic spins become aligned, they all start to get pushed in the same direction. So say this one goes that way a little bit, and this one goes that way a little bit, and then we start having these magnetic fields all line up. We have what's called a net magnetic field. When an overall majority of these electrons are in a certain direction, we'll then have an overall net magnetic field. So the net magnetic field is the alignment of the magnetic spins from the electrons, and they can push on each other, and they can push on other magnetic fields. What they're good for is manipulating other magnetic fields. So we can use these magnetic fields from the electrons to push around other magnetic materials. We can use that to magnetize things. We can use that to attract other magnetic fields of the same direction of opposite pole.